The tides are one of nature's most captivating and rhythmic phenomena, a gentle yet powerful force that moves the oceans, shapes coastlines, and has been intertwined with human life for millennia. At first glance, the rise and fall of the sea may seem like a simple, predictable movement of water. But beneath this surface simplicity lies a complex and fascinating science involving the gravitational pull of celestial bodies, the rotation of the Earth, and the intricate dance between land and sea. Imagine standing on the beach, watching the waves slowly creep closer to your feet, only to retreat hours later, leaving behind damp sand and seaweed. This daily rhythm of high and low tides is something that people living near the sea have long observed. Early sailors, fishermen, and coastal communities learned to navigate by the tides, knowing when the water would be high enough to allow boats to sail freely or low enough to reveal hidden sandbars. But it wasn't until much later that scientists began to understand the deeper forces driving these regular, predictable movements. At the heart of the science of tides is gravity, specifically the gravitational pull of the moon and, to a lesser extent, the sun. While gravity is the same force that keeps us grounded on Earth, it also acts over vast distances, reaching out across space to influence objects far away. The moon, despite its distance from Earth, exerts a gravitational force strong enough to affect the oceans, pulling water toward it. This is the primary cause of the tides. The gravitational pull of the moon creates what is known as a tidal bulge. Picture the Earth surrounded by a thin layer of water. As the moon orbits our planet, its gravity pulls on the water, causing it to bulge out on the side of the Earth facing the moon. This bulge represents high tide. Interestingly, there is also a second tidal bulge on the opposite side of the Earth, where the gravitational pull of the moon is weaker. This occurs because as the moon pulls on the Earth, the planet itself is slightly stretched, creating another high tide on the far side. Between these two bulges, where the water is not being pulled toward or away from the moon, are the areas of low tide. As the Earth rotates on its axis, different parts of the planet pass through these tidal bulges, resulting in the daily cycle of high and low tides that coastal areas experience. Most places on Earth have 2 high tides and 2 low tides each day, a pattern known as a semi-diurnal tide. However, some locations may experience only 1 high tide and 1 low tide per day, called a diurnal tide, depending on local geographical factors. The sun also plays a role in creating tides, though its influence is smaller than that of the moon because it is much farther away. When the gravitational forces of the sun and moon align, as they do during full and new moons, the combined pull creates higher than usual tides, known as spring tides. Conversely, when the sun and moon are at right angles to each other, during the first and third quarters of the moon, their gravitational forces partially cancel each other out, leading to lower than normal tides, called neap tides. While the moon's gravitational pull is the primary driver of tides, the Earth's rotation and the shape of the ocean basins also play important roles. The Earth rotates once every 24 hours, moving different parts of the planet through the tidal bulges created by the moon and sun. As this happens, the water in the oceans must move to accommodate the shifting gravitational forces. However, the movement of water is not uniform across the globe. The shape of the ocean basins, the depth of the sea, and the presence of landmasses all affect how and where the water flows. For example, in narrow coastal inlets or bays, the rising tide can be amplified, creating dramatic tidal effects. The Bay of Fundy, located between the Canadian provinces of New Brunswick and Nova Scotia, is famous for having some of the highest tides in the world. Here, the shape of the bay causes the incoming tide to be funneled into a narrower and shallower area, resulting in water levels that can rise by as much as 50 feet, 15 meters, during high tide. In contrast, in open ocean areas or along broad, flat coastlines, the tidal range is much smaller. Another interesting aspect of tides is how they can influence the flow of rivers and estuaries. In areas where rivers meet the sea, the incoming tide can push salt water upstream, mixing with fresh water and creating a unique environment where marine and freshwater species coexist. These tidal estuaries are rich ecosystems that support a wide variety of plant and animal life, from fish and crabs to birds and mangrove trees. The ebb and flow of the tides help circulate nutrients and oxygen through these waters, making them some of the most productive and biologically diverse areas on Earth. Tides also play a critical role in shaping coastlines. Over time, the regular rise and fall of the sea can erode cliffs, carve out new channels, and deposit sand and sediment in different areas. In this way, tides are a constant, slow-moving force of change, gradually transforming the landscape. For coastal communities, this can mean a constant battle against erosion or the need to adapt to shifting shorelines. However, tides also bring benefits, such as the creation of fertile tidal flats and marshes that provide important habitats for wildlife and opportunities for farming and fishing. The predictability of tides has made them a valuable resource for humans throughout history. In many cultures, knowledge of the tides was essential for survival. Sailors and fishermen relied on the tides to determine the best times to set sail or return to port. Tidal patterns were also used to navigate tricky coastal waters or access shallow harbors that were only passable at high tide. In more recent times, scientists have developed sophisticated models to predict tides with incredible accuracy, allowing ships to safely navigate treacherous waters and coastal cities to prepare for extreme tidal events. One of the most fascinating uses of tidal energy is the development of tidal power, a form of renewable energy that harnesses the power of the tides to generate electricity. Tidal power plants work by capturing the energy of moving water as the tide flows in and out. This can be done using tidal barrages, which are large dams built across estuaries or bays, or with underwater turbines that spin as the tidal currents flow past them. While tidal power is still a relatively small part of the global energy mix, it has great potential as a clean, sustainable energy source. The science of tides is a perfect example of how interconnected our planet is. The movement of the oceans is influenced by forces from beyond the Earth, such as the moon and sun, as well as by the rotation of our planet and the geography of the land. This intricate interplay of factors creates a system that is both predictable and constantly changing, a delicate balance of forces that has shaped life on Earth for millions of years. For many people, tides are a reminder of nature's power and beauty. Standing on the shore, watching the tide come in, it's easy to feel a sense of wonder at the vastness of the ocean and the invisible forces that move it. The regularity of the tides, their rhythmic rise and fall, is comforting in its predictability, a reminder that even as the world changes, some things remain constant. Yet, despite their predictability, tides can also be unpredictable in their effects. Storm surges, for example, occur when strong winds from a storm push large amounts of water toward the shore, creating tides much higher than normal. These surges can cause severe flooding and coastal damage, especially in low-lying areas. In some cases, the combination of a storm surge and a high tide can result in devastating consequences, as was seen during events like Hurricane Katrina or Typhoon Haiyan. In addition to their influence on the oceans, tides also have an impact on life. Many marine species have evolved to synchronize their reproductive cycles with the tides. For example, some species of fish and crabs time their spawning to coincide with the high tides, which carry their eggs and larvae into protected coastal areas where they have a better chance of survival. Other species, like sea turtles, use the tides to help them navigate during their long migrations, relying on the changing currents to guide them. For humans, tides continue to be a source of fascination and inspiration. Artists, writers, and poets have long been drawn to the mystery and majesty of the tides, using them as symbols of time, change, and the ebb and flow of life itself. In literature, tides are often used to represent the passage of time or the inevitability of fate, while in art, they are depicted as a metaphor for the cyclical nature of existence. As our understanding of tides has grown, so too has our appreciation for the complexity of the natural world. The science of tides is not just about the movement of water, but about the interconnectedness of everything on Earth, from the forces that shape our planet to the life that thrives in its oceans. Tides are a reminder that we are all part of something larger, a vast and intricate system that is constantly in motion. In the end, the tides are much more than just the rise and fall of the sea. They are a powerful force that shapes our world, influences the way we live, and connects us to the rhythms of nature. Whether we are watching the waves on a quiet beach or standing in awe of the power of a tidal bore, the tides remind us of the beauty and complexity of the world we live in, and the invisible forces that shape it.